Hey class, this is Gigi from Kauai Community College. In this video, we are going to go backward of the derivatives, meaning taking the antiderivative. So given the little f, which is the derivative function, we want to know what is the original function that will give us this derivative here. So we know that the derivative of tangent, or you should know the derivative of tangent x, is secant square of x, right? So when we go backward, the antiderivative of 5 secant square is going to be tangent square of x, and then the 5 is there. Do I need to do something? Do I need to, not tangent square, but just tangent of x? Do I need to divide by anything? And the answer is no, because the derivative of tangent is secant square multiplied by the constant 5 is it. However, what I am not doing yet is to say plus c, because the derivative of c is 0, so there is actually many variation of the function f depending on what the c is, right? And again, we won't be able to solve for c unless we were given specific conditions about the function f. Okay, next, this looks a little bit more complicated, but guess what? We can reduce that and say 5x to the fourth. This is all divided by x to the third. So take each term and divide it by x to the third. You will have 5x to the fourth divided by x to the third is x minus 6 over x. Okay, so that's how we would simplify that. Take our terms divided by x to the third. Now, then the antiderivative is going to equal to, I have 5x squared, and I have to undo the multiplying by 2 by dividing by 2. So that when I go backward, I take the 2 down like this. That cancels with that 2. That will give me 5x. Minus, and this one is the one where you have to recognize, the derivative of ln of x is 1 over x. So this is 6 multiplying by 1 over x, so that the antiderivative of that is 6 ln of x. And don't forget, plus c. Okay, next we have a little baby function inside, right? So remember the chain rule said that we're supposed to multiply by 3. So I know when I go backward, I would have to divide by 3. And so I would have sine of 3x, because the derivative of sine is cosine. So I would have sine of 3x, and then I would have to divide by 3. Because when I was going forward, and take the derivative here, I would have cosine of 3x multiplied by the inside, which is 3. Okay, so that division by 3 right there is to undo multiplying by the inside derivative. And you can only do that, notice, you can only do that if the inside derivative is a constant. If the inside derivative is not a constant, for example, if little f of x is cosine of x squared. Okay, could you have just said then the antiderivative is sine of x squared divided by 2x based on that reasoning that I said there? And the answer is no. Why not? Because when you were going to take the derivative of big F of x, this is a quotient rule, right? So that would be, I don't know, something really big, and the denominator would be 4x squared, and you have a huge thing up here. So that doesn't work. That does not work. So you only can do basic antiderivative of that type of composite function if the inside derivative is just the number 3. But if it is something like this and an antiderivative is in terms of x, you cannot just go and divide because you would create a quotient, and the quotient rule would apply if you were to go and take the derivative, so that does not work.